Thank you for joining us. I'm Paul Wilson.
And I'm Chris Emhke.
And this is Diesel Performance Podcast. Guys, we got another awesome episode today. We have on Guy Tripp from SoCal Diesel. Guy, how the hell are you?
Yeah, I'm doing great. How are you two?
You know, we're excited to have you on and talk about one of our favorite things, Duramax motors.
That's right. Yeah, SoCal. I mean, when you think SoCal Diesel, it's for one of two reasons. It's built Duramax engines or licenses for EFI Live. But Guy, for any of our new listeners, we had Guy on, I think the first year of the podcast. It was so long ago. It was such an awesome interview. But can you tell our listeners kind of your background in diesel performance?
Oh, gosh. My background actually is in gasoline performance. I was the vice president in charge of engineering for a company that manufactured their own aluminum cylinder heads for racing purposes. And I bought a Duramax pickup to tow my NASCAR late model back and forth to the racetrack, and that began my curiosity into diesel performance. I really didn't know much about it at that time, but my engineering background, my engine building background kind of took over, and we have been pushing the Duramax to new levels ever since.
No, I mean, I don't think this day and age, you know, to see anybody with a hopped up Duramax to not have something SoCal Diesel, whether it's heads, camshaft, you know, or just, you know, complete long blocks, right? Like There's something SoCal Diesel related on these trucks.
I mean, I think of like UCC contenders with Duramaxes, and you're like, oh, it's probably a SoCal.
Yeah, exactly.
Like if you're going to go big power and you're going to do it on a national stage, yeah, it's probably got that name behind it.
Now, Guy, you know, having gasoline as the background, and you said you had, you know, your own Duramax diesel. We're probably going back. We're talking like LB7 LLY style engines, or what was the Duramax of choice that you had?
Yeah, correct. Yeah, it was the end of 2002. I had bought a 2003 LB7 truck, and like anything else, I had to make it my own. I mean, geez, even my stand-up jet ski back in the mid '80s had nitrous oxide on it, so the Duramax wasn't.
So
the Duramax truck wasn't going to remain stock for very long. So, you know, we started looking into what we could do to increase power, and you know, it kind of took off from there. And we've just been leading the industry really in a lot of innovative products ever since.
How do you get started in something like that, right? Like I know you had a gas background, you know the basic understanding of mechanics, but like where did you start tinkering? Like how did that come about with this brand new 03 Duramax? And you're just like, you know what, I'm gonna tear this fucking thing apart. We're gonna figure out how to make this thing better.
Well, you know, it started out innocently enough. I again had access to chassis dynos and engine dynos in my normal course of work every day. And so I was looking to improve the performance. Quite honestly, the Duramax was a little disappointing when I first got into it, climbing out of an LS1 powered truck. And I was looking to improve it. So honestly, I opened up a diesel performance magazine, and I saw a company by the name of Edge that was advertising a chip that you could put in your Duramax pickup truck or plug in this module under the hood and pick up 125 horsepower. And I about spit my soft drink across my desk when I read that, because in the gasoline industry, that was just, there was no way in heck that was just going to be a total scam. And I literally bought one of their modules with the intent to prove them wrong, that I was going to do an A/B test on that. And I was so upset because I don't tolerate people that are taking advantage of consumers in that fashion. And I remember plugging that module in one day just before I went out to lunch. And of course it wouldn't work until the engine temperature came up to operating temperature. So you didn't really feel anything at first. But I remember on the way back, stepping on the throttle of that crew cab long bed 4-wheel drive pickup truck and just igniting the tires for a block. And I thought, this actually feels like we picked up what they advertised. I'm going to go to the chassis dyno and see what we can learn. And sure enough, it was everything that they had advertised. And you know, you would sacrifice a family member for 10 horsepower in the gas world. I mean, I can't tell you how many hours I have on chassis dynos and engine dynos trying to scratch out 5 or 10 horsepower. And to be able to just plug in 125 horsepower, that was just fascinating as heck to me.
No, that's one of the things I would say the diesel community is very spoiled by. I know, like, I played around with some, like, LS gas stuff. Guys will do cams, intake, whatever, and, you do, like, an intake and a tune, you pick up, like, 10, 15 horsepower, or we have customers that come from a diesel and go into the gas world, and they'll call us and be like, hey, I want to tune my gas truck. How much power can I add? And it's like, well, you could pick up, a good solid 15, 20 horsepower, and they'll laugh at you. They'll be like, well, my diesel, I picked up 150 horsepower and 200 foot-pounds. Like, how does this make any sense?
Yeah, exactly.
So it's pretty. It's a different world, application to application.
Well, that's interesting to me as well, because as we talk about what you modify on a gas vehicle to be able to get power out of it, a lot of it has to do with airflow and getting more air pumped into the right areas at the right time. How did that kind of translate into getting into the engine builds? Because you guys aren't doing a tuner and an intake bundle like you guys generally, like we said, we think of you guys as like, the creme de la creme of a motor build.
Well, unfortunately, or fortunately, I guess, I started surfing message forums, back in that day. That was a primary source of information. And I hit upon a thread where guys were talking about having a dyno day. Hey, let's all take our trucks to a chassis dyno and see what they all do. And being the competitor that I was, the racer that I was, I thought, well, I'm going to go to this dyno day and see if I can't set the top horsepower. And so what I did is, being intrigued by all the tuners, the different modules, both the ones that flash the ECM and the ones that you plugged in under the hood, I set out to purchase every tuner that I could find and then go spend a couple of days on the chassis dyno running them, tuner after tuner after tuner, to try and figure out which one was going to make the best power. And of course, we learned about stacking back then. So you had one tuner that you could flash into the ECM, another one that would plug in under the hood. The one that plugged in would just modify the signals that the ECM was sending to the engine and further enhance anything that had been flashed in. So a couple of things happened during that time. One is I found the limits of the Allison transmission very quickly and had to improve that. Went to the dyno day and did in fact take the top horsepower and top torque ratings, and then thought, well, heck, if nitrous oxide was good on my jet ski and my gas car, it might be pretty good on my diesel as well. So did a little research on that. Again, back in those days, nitrous was kind of unheard of on diesels. It was more the propane guys.
Right.
But once we analyzed how it would affect the diesel engine and kind of looked at it as a catalyst that it was, went ahead and installed a 125 horsepower nitrous kit on my truck, and that was even more fun. So at that time, we're pushing a little bit over 630, 640 horsepower at the rear tire. And again, very quickly found the limit of the factory head bolts and head gaskets.
So you're just so I'm following, you're still stacking the programmers and nitrous on top of it, correct?
Yeah, we had the stack programmers. We had a fuel pressure cooler as well, and some nitrous oxide. Yeah.
Wow.
So you did every single thing to your truck that we nowadays would tell people, like, absolutely do not do this.
Exactly, because, A, we didn't know any better at the time, or B, it was the quest for speed. And, of course, the industry has matured over the years, and so we've learned lots of things about why that wasn't a good thing to do. But, so heads came off, and, of course, now I'm a cylinder head engineer, so my background is porting, and I take one look at the cylinder heads, and unfortunately, the Duramax cylinder heads are just absolutely disgusting from the factory. It's like they gave no thought to airflow other than just a way to connect the turbocharger to the motor and the exhaust manifolds back to the turbocharger. It's pretty bad. So, ported up that first set of heads, talked with the ARP people about making head studs for the Duramax world, and their response was kind of the same thing. Why would anybody want to race a Duramax-powered pickup truck or a diesel-powered pickup truck? They had no idea what the industry was like, and I had worked with them for many, many years on the gas side, so they put a little weight behind what I was asking about, and so that's where we started, and then it just kind of transitioned from there. I like to call it failure engineering, because as we push the Duramax to new levels, we find the next part that didn't hold up as well as we thought it might at that power level. So obviously, I shortened up the connecting rods in that LB7 before too long, and as you can see, it just progressed into the motor builds that we have today.
One of the things that I think a lot of with SoCal and Duramax performance is the alternate firing order camshaft, right? It's a staple in probably any higher horsepower Duramax build we do here at the shop, and anything that we do at the shop, we're generally using SoCal alternate firing cams. I've always was curious, like, how did that technology come about? Like, what was the thought process? What was the failure leading up to? Like, how did that come about to say, hey, you know what, we're gonna change the firing order of the motor?
Well, interesting thing when you, again, as we started building more and more of these engines, we started to see trends. And we were involved in the first, 1,000 horsepower or 1,000 rear wheel horsepower engine build back in 2006, 2007. So that was quite the deal when we hit 1,000 horsepower at the rear tires with a truck that was called Nasty Girl. And it was the first twin turbo Duramax. I didn't build the engine. It was built by one of my customers with our parts. We learned a lot about that engine at the time with regard to billet injector clamps, because we found with 100 pounds of boost, we were starting to push the injectors out of the cups on that motor.
Jesus.
But to move further in, as we started to see crankshaft failures in these things, it always seemed that the crankshaft would fail right between the second main journal and the second rod journal. And I won't say always, but possibly 90% of the failures would happen there, and then 10% somewhere else. And so you start to thinking about what's going on with this thing in the Duramax, besides the fact that it's driving a lot of accessories on the front of the motor, gear-to-gear cam, gear-to-gear oil pump, gear-to-gear water pump, of course the CP3 pump. There's a lot of dynamics going on the front of this motor. And I looked at the firing order on it and noticed that the stock firing order ends in cylinder number 3 and begins with cylinders 1 and 2. And so if we loop that all together, essentially what you have is a 3-1-2 hit. So we think of this crankshaft as this big, heavy piece of steel that doesn't really bend or flex, but the reality is there's a lot of dynamics going on. There's a lot of torsional twist in the crankshaft. There's then rebound after that twist, after the power cycle. And so in reality, the crankshaft is quite a dynamic piece. It is flexing and moving around. And when you have that 3-1-2 hit right next to each other, and the crankshaft seems to break in that area, just to me it made sense to eliminate that 3-1-2 hit and kind of move the firing order so that we didn't have that kind of trauma to the crankshaft.
What year was your first development, or what year were you getting into the alternate firing order cam technology?
Ooh, gosh, that is a really good question. After doing this for 16 years, it's kind of hard to put a year on when that was done. I remember we were very, very concerned about whether or not the computer, whether or not the ECM was going to allow us to do that. And so grinding the first cam and then looking at the firing order and saying, well, if the ECM is going to send a signal to cylinder number 3, why don't we just redirect that signal to, the new cylinder based on our firing order, and we'll see what happens. And lo and behold, the ECM didn't object at all. So we had a very good customer with a very high-powered drag vehicle that was setting a lot of records at the time. And the factory crank would last maybe a season of drag racing. And as we started to make improvements with the aftermarket dampers and the internally balancing of crankshafts, we could kind of see improvements on how long the crankshaft would last in that environment. Eventually, we tried the alternative firing order camshaft in that, and it was amazing. The effects were, has the crank not broken yet? Well, we must have hit upon something here. So very successful. And so at that point, after about a year and a half of R&D, we decided to release it to the public.
Okay. Now, again, SoCal Diesel, known for engine builds, right? And you offer, you guys have an array of different camshaft options, and you do full engines and things like that. What goes into, I guess, staging out an engine, right, to different power levels and different weak links? Are there certain parts that, you as an engine builder would recommend for more of a a race application versus like a daily driven application, or what sets some of those standards when you do your engine builds?
That's a great question. What we try to do here at SoCal Diesel is we'll spend some time talking with the customer and kind of get an idea of how he's going to use his motor. We don't believe in a one-size-fits-all deal. We're more of a boutique engine builder. We want to make sure that we build something that's going to accurately reflect or stand up to the environment the customer is going to use the engine in, and whether that's a dual purpose tow, race vehicle or a dedicated race vehicle, the builds are going to be substantially different. And so one of the biggest things we run into is the guy that wants to make, 1,500 horsepower at the rear wheels and drive it every day back and forth to work and tow his fifth wheel. It's just not going to happen reliably. For us, we kind of draw a line in the sand, and we've seen this over years, that right around 850 horsepower to the rear tire is kind of where we draw the line in the sand as far as billet main caps and main girdles. At that power level, we're really starting to put a lot of pressure on the bottom end, and so we'll kind of caution the customer. This is kind of the transition line, and I know other shops may say, oh, that's who we've done this and we've pushed them way farther than that, but I always look at it from the customer's perspective. He's spending a tremendous amount of money with us, and we want to make sure that he's getting the most reliable piece for what he's going to use the engine for. And so we're not going to try and tell him that it's okay to do that if we don't firmly believe that the motor's going to be able to hold up to that in the long run.
That's an interesting way to approach it, because I do think that there's a lot of companies out there that will push and say, oh, yeah, you can run whatever, up to 1,000 horsepower before you're really getting into that. How much does that customization come down to, as you were talking about, as far as street driven and competition? Are you saying I can't have a reliable 1,500 horsepower, or even we'll just say 1,000 horsepower as like a daily driver? What would prevent me from doing that?
Oh, well, no. I mean, the 1,000 horsepower was the exotic race motor back in 2006, 2007. Now it's very much a daily driven vehicle. But you get into some of the things that you have to sacrifice to do that drivability wise versus horsepower. Obviously, we're talking about larger turbochargers, larger injectors, which are going to make the vehicle not quite as fun to drive in a towing application if the guy wants to tow a very heavy trailer. So there's just trade-offs. Anytime you're pushing that higher RPM level, you're usually going to have to sacrifice, something down low. And so that's where we really want to dive into, what is the customer going to use it for? And then we'll build the most reliable piece based on what he is going to use the motor for.
I like that. Good. Okay. How has building engines changed over the last, you guys have been doing it forever, for 15 years. So how has building engines changed over the last 15 years?
Gosh, that is a great question. I think the biggest change is when I first started in this industry, I never had any intention of being a diesel engine builder. My business model was to set the company up as a manufacturer of, high performance internal engine parts. And then we would design those parts, manufacture them, and then send those out to the other shops for them to go ahead and assemble and build the engines. And what we found was there was a lack of qualified engine builders at the time. We were sending a lot of parts out there that were just getting destroyed, and for silly reasons, because guys weren't checking clearances properly, or, maybe didn't have the background that they should. So what we've seen, I think, over the years as the industry has matured, and I've noticed it even in speaking with different shops and customers on the phone, is now we have a pretty big selection. We have a lot of really good companies out there that are qualified diesel engine builders that'll do a really great job in assembling these engines for the customers. And I think that's really been the biggest thing, is that the industry has just matured. There's more companies out there that are manufacturing parts, and good quality parts.
Now, being primarily a Duramax, engine provider. We LB7s, LOIs, LBZs, LMMs here at Calibrated. There's a lot of differences in those engines, but there's also some similarities, right? And then you get into the LML, a little different, and then you can get into the newer motor, the L5P. What's R&D been like, or have you guys done anything R&D wise with that L5P platform? And what are some of the differences that you've seen from prior year 6.6 engines?
Well, would it surprise you to learn that we've already built a couple of L5P stroker engines?
It would not surprise me. I would expect nothing less, Guy.
Why?
So,
what are they doing with their trucks? What do you like? Why?
It all goes back to the first, I think, Model T that came off the assembly line, right? That was a great vehicle. And then when the second one rolled off the assembly line, surely somebody needed to know which one was faster. So the L5P truck owners, that platform, as soon as you have more than two trucks or more than one truck available, somebody's going to want to go faster than the next guy. And so that's what really drives it. It's amazing. Every time GM, releases a new platform, we start getting the phone calls. Hey, do you have anything for this? Are you ready to go? So we started in on it right away. So billet stock stroke cranks, billet stroker cranks, ported cylinder heads, camshafts. I mean, we dove right into the L5P platform and all the supporting parts as well. And so we're starting to see that engine start to really mature as far as a race motor.
Okay.
What? Real quick, Chris, I want to dive into something. Ported cylinder heads. When we talk about that, is it simply just make all of the orifices larger and therefore it will flow more air and therefore it's better? Like how do you decide enough is enough, or how to port a cylinder head to get the most out of it?
Oh, that's a great question. So one of the things that got me excited about the Duramax engine, and the reason that I purchased one in the beginning, was that it was the first light pickup truck diesel engine in North America with 4 valves per cylinder. When you look at what the 7.3 Ford was at the time and the 5.9 Cummins, they were both 2-valve motors. It was also the first motor with aluminum cylinder heads for the light pickup truck diesels, which again, being an aluminum cylinder head engineer, that was very intriguing to me. But the real difference between 2-valve per cylinder and 4-valve per cylinder comes down to airspeed. You might be able to get the same quantity of air in and out of the motor with 1 intake valve versus 2, but having 2 smaller valves and 2 smaller ports is going to increase the airspeed. So the velocity of the air in and out of the engine is going to be much quicker, much greater. What does that mean? Well, bottom line is that comes into throttle response. That's your transition. So when you're stepping on the throttle and you're waiting for something to happen under the hood, we're looking at air moving into and out of the motor. Those smaller ports are going to help get air into the motor quicker, get air into the motor, or out of the motor quicker, spool the turbo. It's all good things. And so that needs to be kept in mind when porting a cylinder head as well. It's not about just making the largest port you can and the flow bench tells you you've got a really great number there. It doesn't mean anything if all you've done is slow the airspeed down. It's fine in a dedicated racing application where it's just nothing but wide open throttle. Although there are arguments there that you still have some transition. In a drag race motor, you're still going to transition from one RPM to another. Sled pull motors basically are going to maintain a somewhat constant RPM going down the racetrack. But particularly for drag racing and then onto the street, that transitional throttle response is really, really dependent upon not only the amount of airflow, but that airspeed. And so making that port efficient is our number one goal. So for a given valve and a given port size, we know that it should move a certain amount of airflow. And if it doesn't, then that means the shape needs to be improved. It's not about making it larger, it's about improving the efficiency and maintaining that airspeed, be it a cylinder head that's targeted towards a street version or a cylinder head that's targeted towards a race version. We run that balance between overall airflow and airspeed.
Man, I knew this shit was over my head. No, I'm just joking. I totally
Paul
understand.
And I are looking at each other like, okay.
Like, oh, good. Another person we're interviewing that's way smarter than us. Great. No. I get it. That's a really, really good explanation, because in my head, I'm like, well, I've seen an LB7 intake horn. I've seen a ported LB7 intake horn. I've seen a guy bust a Dremel out and port his own LB7 intake horn.
Right.
I don't know what's better. Like, just, I don't test that stuff. So it is really interesting that you guys are chasing down a dynamic of this that I don't think most of us think about. I think if I was shopping for it, I would shop to see whose number said the biggest number. I don't know what number we're measuring
I think
ported cylinder heads
as
in.
guys explaining this, I kind of back into it from a turbocharger question with guys that bigger isn't always better. It's a balance for the application, or it's a balance of a compressor and a turbine to work together.
Yeah.
It's kind of that same sense with the head. You can open up whatever port as big as you want, but there's only so much air that's going to come in and out of that valve, right? So it's about that balance at that point.
Yeah, and I guess I never really thought of cylinder heads as a way to address transient throttle response, right? That's like a favorite phrase around here, but
but it makes sense.
But it does, yeah. No, it's totally logical now that somebody's explained it to me. Okay, all right. So now I got a handle on ported cylinder heads. We've talked about alternate firing order cams. What are some of the other staples in your guys' product category? What else are you really proud of engineering over at SoCal?
Gosh, the list goes on. I'm ultimately, obviously, very proud of the entire body of work the company has done over the years. But if you really look at a lot of the things in the Duramax world, we've really been a pioneer and innovator in just about everything Duramax. Obviously, the billet crankshafts. I mean, we released billet crankshafts back in 2007. Ported heads, CNC ported heads were 2006. The billet main caps, main girdles, the injector clamps were a big thing. That solved a really big problem, specifically with the LB7s, where we were pushing the injectors off the seat there, and then having engine failures because of it. Piston design. We worked very closely with Maul on the piston design. In the beginning, we used to modify the factory pistons.
D-lip
The term
LB7s.
D-lip.
Yeah.
Yep, the term D-lip in 10, that was coined here at SoCal Diesel. So the thermal coating, putting a thermal barrier on the piston to help reject heat, not let the piston absorb as much heat so that it doesn't get to the point of melting. All good things. Gosh, the list continues to grow.
Can I hold on to D-lip LB7s and just, I'm sure some of our listeners don't know what that means. I'm sure it's not me. Can you walk us through what is a D-lip LB7 piston?
Oh, again, another great question. So the factory piston for the Duramax, actually all of them, has what's called a reverse entry lip bowl. And what that means is, we picture kind of this bowl, or if you look at your cereal bowl, you kind of have vertical walls. Well, what this reverse entry lip is, those vertical walls kind of converge onto the center of the bowl. So they don't come up straight on either side. They kind of come up so the top of the bowl is actually a smaller diameter than the bottom of the bowl. And the idea there is for the injection, the fuel stream to be injected right at that lip or just below that lip. And that causes the fuel stream to tumble in the piston bowl. And as it tumbles, it atomizes and it mixes much better, so you get a much better burn. The problem is that lip, because it's kind of hanging out in the wind there, has a tendency to get superheated and crack. And so I did some research. There's a lot of SAE papers on piston design, and they talked about how this bowl design was very, very good for emissions, but also not so good for durability with regard to the existing power level. So as the quest for emissions moved forward, the manufacturers found that as they introduced this bowl design, they also had to lower the power level to keep the pistons from failing. But then there was another paper that kind of ran a contrast between the earlier bowl design without the reentrant lip and the new bowl design as used with Bosch common rail injection. And the theory was that the common rail injection was such high pressure, high fuel pressure, that it was doing actually a much better job of atomizing the fuel than the bowl would. And so I read a study by one engineer that on a single cylinder engine that did a back-to-back test on that, and he in a sense proved it. And so I thought, well, now I know I can go in and modify these pistons without fear of compromising something else. And so what we did is we started removing that lip on the piston, and then we would cut them 10 thousandths off the top of the piston just to make up for the brand new rods we were putting in there and the milling of the block when that was being straightened to make sure we didn't have too much piston protrusion. And so there was born the Lip and 10, and that was the way all Duramax pistons were modified for quite a long time, until I got to talking with the Emhke engineers about actually manufacturing them that way so that we didn't have to do these secondary modifications.
That's so cool. That's another one of those that, like, honestly, we've talked D-lip pistons, I think, with you before, but it is one of those that it's so easy to overlook some of these major strides that were made that other improvements have been built off of, right? Like where LB7s are able to be taken today are because guys like you were doing this entry level work. And I'm sorry, you said reading SAE papers? I couldn't think of something I would like to do less right now. So it is a lot of this industry, this performance, this fun, the burnouts you see, the dumb videos you watch on YouTube. It actually tracks back to some engineer like Guy sitting down and doing the homework and doing the math
the tuners, and nitrous and the whole 9 yards,
and doing all of these things that we laugh about now to kind of get us to this point, which brings me up to where do we see the future? We got 3,000 horsepower on 2 different trucks on 2 different dynos now. Or one, let's start there. One, how long until you get us a 3,000 horsepower Duramax?
Oh, I think that is going to come sooner rather than later. We're working on some things right now that I think are going to allow us to do that. Hopefully, maybe before the end of this year.
UCC is like 40 days away, so you're talking at UCC. SoCal is promising a 3,000 horsepower Duramax. You heard it here, folks. No, I'm just joking. But by the end of the year, that's crazy. Does anybody know? Are you guys tracking like what is the current highest horsepower Duramax on record?
I don't track that because everybody's measuring stick is a little bit different.
That's bullshit.
So one dyno versus another dyno and so on and so forth. So I like to track wins. Did the customer win? Did the customer win the event?
Okay.
And so again, we're looking at, one of our customers, UCC customer, has been and dominated UCC for many, many years in the Duramax world, and that would be Wade Minter.
Okay.
And he was a great research test bed for us. And he would go out and compete and win and do very, very well at UCC year after year. And what a lot of people didn't know is after competing at UCC, he would load the truck up in the trailer, take it home, and then continue racing all of his normal drag racing events for the entirety of the year, and then send the motor back at the end of the year for a little freshen up, for some investigation, just to make sure everything was happy. It wasn't just a motor that was built for just one event and let's go and throw everything at it that we can, and if it blows up, oh well. It wasn't that way at all. It was reliable horsepower, which proved to dominate the event for many years.
Absolutely, yeah. Wade Minter, one of the nicest guys you're ever going to meet at a track.
On the show multiple times.
Yeah, you cannot talk to Wade and not be smiling. One of the few privateers left in high level of competition. I think most of competition in the diesel community is, I don't want to say taken over, but dominated by shops that have shop budgets. And a shop budget compared to a privateer budget is very, very different. So the idea that he's building it to go to UCC, I remember interviewing him probably 5 minutes before and then also 5 minutes after his first time ever sled pulling, which was at UCC. He was a riot. I mean, and the truck held up. I think that was always the most shocking part. We see a lot of guys enter, register to go to UCC. A few less of them show up. And then a few less of them make it there to the sled pull, and a few less of them drive off that sled pull track. Right. So to see Wade really representing the Duramax and SoCal in such a big way, I think that's been definitely a big win. Okay, then the second.
Put together,
go ahead.
Wade put together a great team behind him. I mean, he had a lot of help from the guys at Tripps Diesel, and it was really the team. It was a team effort. They did such a great job, and we're exceptionally proud of what those guys accomplished, because they were the top finishing Duramax or one of the top finishing Duramaxes year after year after year.
Absolutely.
Guy, I got a question, right? You've had your hand in pretty much every Duramax motor. What's your preferred engine? What's your favorite Duramax engine out of all of them?
That's a good question. Again, I hate to keep saying that, but you guys have some really good questions, and I appreciate you asking me that. After working on these things for 16 years, I can't say I really have a favorite.
Cummins 5.9.
To hate.
Sorry, Guy. Sorry.
I have learned to hate them all.
The only answer that was going to be better than Cummins 5.9 was I hate them all. That sounds about right.
No, in reality, I mean, they're all good platforms. From LB7 through LML, there's just been tiny little changes to the internals of the platform. The bigger changes have happened external with regard to injectors and ECMs and fuel pumps and stuff like that. So it wasn't really until the L5P that there was a drastic architecture change. So for me, when somebody says, well, what's your favorite engine to go racing? It really comes down to probably what ECM am I going to use to control it? Am I using a factory ECM or an aftermarket ECM? After that, it doesn't really matter because the internals are going to be there. It's just all about control and of the engine itself with the electronics.
I think you nailed that one on the head. You know, from us, I asked that question, and I didn't ask it from an engine builder perspective. I asked it from an ECM compatibility perspective. So that, well played.
Yeah. We're always so excited to talk with you. So we're looking for 3,000 horsepower out of a Duramax from SoCal. Is there anything else in the future that our listeners should really keep their eyes and ears open for?
The limit on the Duramax right now really comes down to the block. We can only go so far with the factory block. So there's going to have to be an aftermarket block introduced that will be capable of holding up to this horsepower. And so that's probably going to be the biggest improvement that we're going to see. All the other components are there and capable of doing what we need to do, but so far the block has proven to be the weak link with failures once we get up into those upper 2,000 range horsepower numbers.
I love it. Awesome. Well, Guy, thank you so much for setting aside so much time for us and for our listeners. We really appreciate it. If somebody wants to learn more about SoCal Diesel, where can they go?
Our website, we built our website around providing information, and we hope that if the customers value the information we've provided, then maybe they'll honor us with a purchase. So shop.socaldiesel.com is where you can find not only all of the Duramax parts we manufacture, but torque specs, other formulas and recommendations, basically anything the end user needs to help them succeed in their Duramax racing endeavors.
That's so cool. Thank you so much again. Guys, for today, this has been Paul.
And Chris.
Thanks for listening. Thanks for joining us today, guys. This has been Paul Wilson.
And Chris Emhke.
Make sure to like and subscribe, and we'll talk to you again soon.
I have learned to hate them all.